doing.
Nice, Happy Meal. Wow, you're getting into some value functions. All right, Christian. We're about 5 minutes after if you want to go ahead and start.
Yep, just share my screen. I should put it at 720, right? Just
Yes,
so
please.
that.
Yes, please.
Alright, can everyone see my screen? Is there any lag or?
Looks good on here on my end.
Alright. Okay, so if everyone good, we'll just start today. So, hopefully today we can actually go through the different types of variables that there are in Solidity. So there's state, local, and global variables. But before we jump into that, what we're gonna do right now is just write a very simple function. Just an addition function. So before I start, what's the first thing that all contracts should have? What's the first line that I should put up here? Does everyone can someone just type in the chat? Yep, it's the license, and I can see that actually Happy Meal used a different license, which also works, which is perfectly fine. All right. So today we'll just be using you guys can choose whichever version you guys want to use. But I'll just stick with 0.10 today. All right. So now we're going to start writing our first ever contract. So to start writing a contract, you start with the word contract, and then you just have to name whatever you want your contract to be. So I'll just name it add. Wait, before I start, does anyone have any questions from last week's task about changing changing it to your Discord name, printing it? I'm gonna guess that's a no. Okay. So to start making a function, it's very simple. You just have to define that you're writing a function by just stating that you're, function. And you just name your function. So whatever you put after the word function will be the name of your function. I can't spell. All right, okay, I'll just name it adding. And then you put these brackets, just normal brackets. So then once you have your normal brackets, you can define your variables that you want. So in this case, because we're trying to add two different numbers together, you can easily put x and y. So we're going to name the first input that whatever they put in as x and the second input as y. But this is just placeholders for whatever the input is in the future. So we also want to make sure that they don't put in any kind of thing. So obviously we don't want them to be putting in words. We don't want them to be putting in letters because this is a function that we want to add. I can see more people joining the class. Should I restart or?
Welcome, everyone. Welcome, welcome. If this is your first class, you can see the first class that we had on YouTube through our official links. Today we're going to be going over functions. Variables.
Variables and making a function.
Variables and making a function. So we start off just as a quick recap with our license. Can you highlight the license for us, Christian? That's that green text up top. We just copy and paste that. That's nothing we really need to get that deep into. The second line is then pragma solidity or version of solidity that we're using. We use the little caret to show anything above version 8.10, 0.8.10, and we close the line with a semicolon. Now we're ready to start the contract. We then name the contract. He's named it add in this case. And we use a squiggly bracket to open the contract and start whatever our contract's going to be. He started off this first contract by creating a function that adds x that states what x and y is. When we'll get deeper into it. Here we go.
So just to prevent people from putting in letters or putting in different variables that can affect our addition function, because we only want numbers, what we can actually do is make sure that it can only be an integer by putting int. And once you see it change its color, it shows that it's going to be an integer. But because we don't want, we also want to make it sure that it's an unassigned integer. We just make sure it's a uint for both x and y. So once after this, we just type external and pure. So external pure just basically means that this is a contract that people can actually write their or interact with, so that they can actually put in numbers, they can put in whatever they want. So this pure here is what changes it. So we'll go a bit deeper into that. Yes, pure means pure won't change the smart contract. So gas is actually something very different that we'll get into in the further lessons. But right now, gas isn't something that we can actually change here, because there's a whole different code that you have to write for gas. So this part here is just two different things. It can be either pure or view. Pure means that you can interact with the contract. View means it's read-only. So those are just the two main differences. So after this, we just want to make sure that that's basically the contract that's basically the function for adding. And once we're done, we just have to write return. So we want it to return as a whole value. So we want to return it as a unique integer. And once we're done with that, that's basically our first our first function, sorry. But what we want to make sure is right after every function, you always have to end it with return. And what you want to return it with is the two variables that we have, x and y. So we can just x plus y. I'll put some spaces to make it a little bit easier to see. And don't forget, you guys must always put the semicolons at the end of your line. So this is basically all you have to do for a function. It's very basic idea of what a function is. It's not too complicated. It's just very straightforward. And once you're done, you can compile it, test if it works. But for some reason, sorry. One second. Sorry, I must have typed something wrong. Sorry. So right here, what I did wrong is here you actually have to put the word returns. So that's why in coding it's very important that, even if you have a letter missing, it could go very wrong. So down here is the word returns. So you want to make sure that whatever value these two add up together returns as an unassigned integer. So it just shows how important your spelling is for coding. So once you're done with that, you just have to compile it and you have to just deploy your contract. So what you can do is, right now you can just put two different numbers. So I'm going to put 2 and 3. And if you call the function, it will add it up for you. So it's a very basic function, just trying to add up everything. So can you guys try and see if your contract works for you and if you guys can actually get the addition function working. Is anyone having any issues creating this function?
Feel free to screenshot it and post it in chat. Get some XP.
Nice.
No, you're faster than I am. Yeah, Solidity's a great language, huh? Give it up for Dr. Gavin Wood.
Has everyone else tried it? All right, so we'll also just create us another function right now. It'll just be a simple subtraction function. So does anyone know from what we've done so far, who has a rough idea of how to change this addition function to a subtraction function? It should be very simple. Just changing one or two different things, and you should get a subtraction function. So I want you guys all to try it and see if you guys can post it into the chat. Yep. So actually, I'm gonna just do this and deploy it again. All right, so I'm actually going to show you guys this. So let's say I have a small number x and a bigger number y. And if I call it, why doesn't it show that? It should be -2, right? 4 and 6. Why do you guys think that, it's not showing a -2? Does anyone in the class know? You're close. Happy Meal, you're close. So integers can actually, if this was just int, it would allow negative numbers. But because we're using the unique integer, uint, uint only allows positive numbers. So that's the difference. Yeah, from the last class, which we did, see where it is. Yeah, so here. Integers can actually be from any values from negative to positive, but unique unassigned integers can only be positive numbers. Yep, good job, guys. All right. So now that we're done with that, we can actually get into different variables. So right now, just to let you guys know, there's 3 main variables in Solidity. There's state, local, and global variables. Yeah, no worries. Once your computer's working again, hopefully you can try some of this. If you do have any issues or you encounter any issues during the week, do feel free to mention me in chat. I'm more or less always on. I can always come up and help. All right, so now we're just gonna look at writing what a state variable is. So like always, Oops, sorry. So state variables are basically variables that are on the blockchain. Adding function. Yeah, that's a good one, kind of.
And if you're just joining, I've just posted the link to where we are, remix.ethereum.org. You can practice writing out some contracts with us.
Yeah. So does anyone have any questions for the function as of now?
Nice. Chad, you've put return x minus y. You've named your function adding. So
Sorry, that was just because I was showing. Yeah.
Kendall, you're funny. Yeah, same thing, line trash. Make sure you've got a return x space plus y semicolon.
Yeah. Sorry, I was just using the minus just now to do as an example.
And if we look
But
really quick at line trash's example here, we can see that he's opened the contract with a squiggly bracket. Then there's another open squiggly bracket at the end of pure returns uint. So he should have two closed brackets, closed squiggly brackets at the end. One to close the function or the return, the other to close the contract itself. It will not deploy the contract if you do not have everything wrapped up nice and tight with a bow. So just make sure you're closing. In Remix, it will automatically, when you open a bracket, it will automatically put a close bracket right after it. So you can just feel free to type within those brackets. But when we're writing here on Discord, just be very technically minded. Nice, Happy Meals ahead of us. All right, you want to get into subtracting?
yeah, I already did the subtracting.
Oh, yeah, sorry. What do you want to start with? The state variables?
Yeah, let's just start with state variables. So state variables are basically things that are variables that are inside the Solidity contract, but they're different from local variables because local variables are solely for inside functions. State variables are for inside the contract. So to make a very simple state contract or state variable contract, just start as usual with the word contract, variables, and we open with our squiggly bracket. So we're just gonna define our state variable as uint, public number. So we're defining it as, so we're gonna name our variable a num. So this is the name that I'm giving to what we're gonna define later. So right now, this is what we are, or in my version, I'm gonna call it num. It has no value as of now because I haven't set any value. Now we're gonna use what we did just now and using functions change what the number is. So function. So let's say let's set a number for this value because right now there's no value for this number right now. So let's create a function that will create a value for it. So we'll just say that we're gonna set the number or set num, and then we're gonna make sure that it's a uint because we did say that it has to be a unique integer or unassigned integer. Num. Sorry that I type very slow, but it's just how I type. And we're gonna make sure that it's an external so that people can interact with it. We are gonna open up the squiggly bracket, and we'll say num is equal to num. So this basically means that whatever value that we assign or whoever is interacting with the contract assigns this number. So this number will then equal to our value that we have as an open source right now. Then we'll do one more thing after this. Actually, let's just run this first. We'll run this first and show you what it means. So I'll compile it. I'll deploy the contract. And so like right now, if I call the function of num, because I have not done anything, I've not set the number to what it is, it'll just show up as 0, right? Because we haven't assigned any value, we haven't assigned any uint to it. But let's say I call it 420, right? And I set the number and I interact with the contract. Then once I call the value again, it'll actually show up as the value that I set it as. Does everyone understand that, or should I repeat that again? Your function. Which one were you talking about? As in this one? Yes. So it's kind of like a setter function, but what you're doing is, let's say, okay, I'll do it again because I think this one's a little bit more complicated. So what we're doing here, so I'll just do the entire thing again with you guys. So we're writing our contract, and right now you can name it whatever you want. This is, as usual, naming the contract, state variable. Right? You open brackets, you can start editing your contract, and we're going to assign an open variable. So that basically means that we're creating this value called num. So I'm creating this word here. So I'm signing num as whatever number I want it to be, which I'm just going to type out the full thing. So I'll say this is a number, right? So this number right now has no value, it basically equals to 0 because I have not assigned any number to it. Remember from last week, we can actually assign value. So if I put this as equal to 1, 2, 3, then my number, this word has a value of 1, 2, 3. But because I don't want to assign a variable as of now, I want it to have the person that's interacting with the contract assign the value. I can just leave it as this. So that right now this has no value. And and once we write the function afterwards, here, function set num. Oh, sorry, can't spell. So function set num, you can actually name this as whatever you want. So this is just the name of the function. Remember, whatever you type after the word function, is just the name of your function. It doesn't have to be set num, it can be add, it can be whatever you guys want. But I'm just going to make it very straightforward. So I'm just going to say setting number, so that you guys will know that we're setting this number here. And we want to make sure that it's a uint. So uint underscore num. So this just basically means that this is the assigned variable that, so once they interact with the contract and once they put, like for example, once I put a number here, I'm putting it to the point where whatever number they set will be set as this value instead. So I'm not going to put it directly back into the word number yet. So as of this point, my number still equals to 0, but my value here, num, is equal to 420. But once I put external, another squiggly bracket, and I set it to number is equal to num, to my underscore num. This basically means that whatever they interact with the contract, that number will be equal to the number that I put up here, which is 0.
let's do a quick recap in case we lost people. So first we started with our state variables contract. We created an unsigned or unique integer. We've made it public, and we've called it num, N-U-M. We've closed the line with a semicolon. Give me a thumbs up in chat if you agree before we even get into the function. All right, great. Fingers crossed. Nice.
Sorry.
Then we've created the function by typing function. The function is setNum. Here, I'll post a screenshot. And we've then created the open bracket of uInteger underscore space underscore num close bracket external, meaning it can be called from outside the contract. We're going to open that function with a squiggly bracket. I'll post in chat right now.
I'll copy paste mine and post it into the chat.
Perfect. Nice. Yep. Now that we've got that function open with that squiggly bracket at the end of the line, we're just setting what num, that uint that we set, is equal to, and then closing the line. We then close the function, then have the close of the contract as well. Before we move on, is anybody lost? Does anybody have any questions? I'll give you 6 seconds to type in chat. All right, looks like we're good.
All right. So let's say that after we assigned the number, we don't want it to be that number. We want to reset the number. So now we're going to write a simple function to just reset the number for us. But when you guys type it, make sure that you're still inside the brackets because you want to make sure that the function is still inside the contract. All right, so we'll just start writing function. Really bad at spelling. Function, let's say we're going to reset the number. And since we are resetting the number, we're putting it back to 0. There's no need to assign any special case for this. We're just going to make sure that it's external so that people can interact with the contract. Open up another squiggly bracket. And what we're going to write here is we're just going to make sure that the number is equal to 0. Boom. All right, don't forget your underscore right in front of your second num. Otherwise, you're just going to make sure that, because that function is just basically saying that, number is equal to number. So you want to make sure that you have this underscore here because you assigned an underscore here. Otherwise, you're just saying that this value is still the same as this value, which has no value at that point. All right, so just to show you guys what this function here does, I'm just gonna deploy it for you. So let's say we set the number as 1, 2, 3, and we set the number. And now we don't want this number anymore. We want it to reset. You see how we have a function called reset number here because we called it reset number. Once we click on it and interact with the contract again, it will automatically reassign it as 0. So you can actually set it to whatever you want if you redo this. Once you set a number to 5, you interact with the contract, but you reset it. Whatever number you state here, once you interact with this contract, that value will show up. So that's just a very easy way of how people reset. That's a very easy way to reset the number. And now I'll also show you the difference between, because just now we showed you guys what pure is. So now I'll show you guys what it is, what view mean. So let's say function get num. So we're gonna write a function that just shows us whatever the value of number is. Because right now we have two different functions that we can set the number and reset the number. But what if we just want to see what the number is without having to constantly change the number or reset the number? External view, which just basically means this is a read only, that they can't change the value of whatever this is. They can still interact with it, but they can't change whatever value it is. Return view. We open up another squiggly bracket and we just tell them that we just want them to return whatever we set as a value, num. Does everyone get that part, or do you want me to repeat this? So this word view, it just basically states that this is it tells Solidity, or it tells the whole blockchain, that this is a read-only contract. This is a read-only function. You can't really, it doesn't change, it doesn't make any updates to the blockchain. It's purely just read-only. There's no changes. These two functions here will change whatever's in the blockchain. It'll make updates, it'll change your values of what this is. But this is a read-only, so you can interact with this as much as you want, but it'll not update the blockchain. It will not change anything.
Yeah, thanks for letting us know. Happy Meal. Yeah,
Yep,
it's
thank you.
returns. Yeah.
Sorry, I had like 2 hours of sleep. Okay. Yeah, once we are done with this, we just compile the contract. We can deploy it again. And I say that right now, num is still a 0. Let's say I interact with the contract and I set the numbers 1, 2, 3. Both values here should show you 1, 2, 3. And if I reset the number, both will also go back to 0. It's just this is just to show you what view really does. It just tells you that this is a read-only contract. So why use Remix Ethereum? It's because this actually doesn't update to the actual blockchain. It's a very easy way just to test contracts to make sure that it works before you upload it to the blockchain. So it seems as if we're interacting. It's very close to what it's like to interact with the actual blockchain contract, but it doesn't really do any big updates. It's just to test, basically. Yep. Is everyone good with state variables and functions of resetting and setting? Yep. Okay. So now I'll just show you the difference between, because a state variable is something that interacts with the contract. Now I'll show you what a local variable actually does. So the difference between local variables and state variables is that local variables is variables that are put inside the function. So you can actually put a value inside a function, and if that function is not interacted with, that variable will only stay within its function. It will not be stated inside the blockchain. So we'll just start with our very two important lines, our license and our Solidity. And we'll just start writing our contract, local variables.
Let's restate that difference really quick. So state variables are stated. They're for forever. Local variables are just local. That's
The local variables are local to the contract that you're writing. Saved on stack. Um, what do you mean by? I don't think that's a thing. So there's only three different variables. It's either um, global or state or local. There's no saved on stack. Give me 1 minute, sorry.
I think that's for the card game Magic the Gathering, by the way, to save on the stack.
Give me 1 minute, sorry.
Take your time. Let's quick review so you go up to create the new document, and you want to name that. The first one you should have is state variables dot sol. Now we're on to the local variables. Yes, I am a nerd. I do love Magic the Gathering. But yeah, so just that little new document. Make sure you're not creating a new workspace. You can keep it within the same workspace.
Yeah.
Test.
How do you test again?
Yep.
Yeah, you see how there's, after you compile, you see that thing right here, the one that looks like an Ethereum logo. You just have to deploy your contract. So let me go back to that I've written. After you compile the contract, you go here to deploy it. And once you've deployed it, you can actually test your function here. Yeah, you can have auto compile run if you want to. So you can actually just go here and turn it on. But I get annoyed because it just comes up with red flags if you're halfway writing it. So it's up to everyone how they want to do it. Because at the same time, you can just, once you're done writing, just press Control S and it auto compiles for you. Yeah, for people that have OCD, yeah. You can also just easily press Control S as a shortcut to reset the to compile the contract and then deploy it. You're lost in the variables. Okay, so actually, I'll write a very simple thing here to help you show the difference. So let's say for local variables, I define uint public I. I'm going to state the variable as I. My uint as I. I'm going to state my bool as B. I'm going to state the address as my address. So these values right now have these assigned things have no value as of now because I have not set any value for it. So what I'm going to show you is the difference between a local variable and a state variable. So I'm going to write a function now. So the difference between local variables and state variables, as you'll see very soon, is that local variables are outside of the function. And whenever you call from outside of the function, you'll get whatever the variable of the local variable is. Sorry, the state variable. But once you start writing inside a function, that's the local variable. And if you unless that function is called, you will not get the value of the local variable. Is variable like law in this exact space? It's not a law, it's like a set value.
Just like an algebra class when you have y equals 4, that's just a variable. X is the variable. Yeah. And we can either have that variable be state, which means it's permanent what it is, or it can be local, which is just local within this contract. Yeah, there we go. Function, aha. I like that.
All right, so we're just write our simple function. So let's say that in this function, I define uint as x. I give it the value of x as 1, 2, 3. State applies everywhere, local applies within the contract being written. Yes, that's basically what it means. So state is whatever interacts with the blockchain, and it's basically almost similar to global, but that's something we'll get into later. But state is on the blockchain, local is inside its function. We're gonna set the bool, and we're gonna call it f, and we're gonna say that it is false. Then usually there'll be a whole bunch of other lines of code here, but it doesn't matter. So let's say that x is equal to 456, and that f is true. So these values right now are only inside the function. So these values here are what we call local variables because they're true to the function, but they're not true to the blockchain unless it's interacted with. And I'm going to put I here, I as equal to 1, 2, 3. I'm going to put B, which is what we call a bool in the public, as true. And my address as address 1. So this isn't something you really need to know. It just sets the value as like 1. It adds 1 to the value. So if I compile this contract, oh sorry, see I forgot semicolons. This is just, please don't forget the semicolons. Everyone always forgets it, even I do. But once you compile this contract, it works. All right.
You've got a plus
So
next to your x value underneath your bool.
no, that's fine.
Okay.
That's fine. That's just adding or equal to. All right. So once I called it, let's say I don't interact with the function yet. If I call b, it says it's false because I have not set anything. And for booleans, it automatically sets as false. If I call my function, my uint I, you guys can see that it's 0. If I call my address, it just gives me a blank address because I have not set any value for the address, right? That's because these are the state variables. These are the variables that are open right now. I have not interacted with my function that will give values to these things. And therefore, no matter how much I interact with these on the blockchain, they're going to give me the same value. But once I interact with the contract, and here I set my I as 123, my boolean as true, and my address is that. You can see once I've interacted with the contract or the function, these changes because I actually set a value. So until the local variable inside the function has been interacted with, there is no way, or it will be impossible for these to actually change its state variables. You guys can see how all these values change as soon as I interact with the function. So that's the difference between local variables and state variables. As long as the state variables have not changed, it will stay as its value until a function or anything has been applied to it. Does anyone have any questions about this part?
Go ahead and post just your deploy part.
So we're able to see as we get. Yeah, I mean, once you get very used to reading or writing your own contract, yeah, you can more or less tell from reading it through Etherscan. You can tell what the function does, you can tell what it's going to do. But most contracts on the Etherscan, they're about the same. They just change the values of what their integers are for how much they want to charge you for their NFT or how much they want to charge you for gas. So that's different, but most of the contracts are very similar. The idea of the contract is very similar. Private or internal? Oh wow, you really read up. Okay, that will be something we'll get into later because I don't want to overcomplicate stuff today. Because we're already talking about three different types of variables, which might confuse a lot of people. I don't want to get into having it private or internal. That's a very good question, but we'll get into it in the next lesson or a future lesson. So does anyone else have any questions about this, or can I move on to our last thing of the day? I'm gonna assume that no one has any questions as of now. If no one's asking in the chat. All right. So the last thing we're gonna get into would be global. So global contracts are basically, global variables, sorry, are basically variables that are out in the entire blockchain. And it's more or less set so that everyone can see. So things like when you interact with a contract, things that you put as global variables is like the timestamp that you interacted with, the block number that you're interacting with, and the address that it's going to, and the address that it's coming from. So things like that is what we call global variables, so that everyone can see. Like when you go to Etherscan, you can see which address it's coming from, which address it's sent to, the timestamp that it happened, and the timestamp is always in seconds. And then you also see the block number that it's interacting with. So let's write a simple contract. Let's say global variables. So let's say the function, I will name it global. External view, because this is usually most global variables are always just view, because you don't want it to be able to change the timestamp that it did, change the address. So the second you put this to pure, anyone can actually change which address it's being sent to. So returns, and we're gonna leave that empty for now because I want to go into the next part before I change what we're going to do there. Open up another squiggly bracket because you want to define what's inside your function. So let's say that we want to know which address is coming from, right? So let's say the address of the sender is equal to message dot sender. So what message dot sender means is basically the address of whoever's interacting with the contract. So like, let's say I use my MetaMask, I interact with the contract, my MetaMask address will show up here. And we're gonna set that address to this value. Then we also want to know, usually most contracts also want to know, the timestamp of when it happened. And obviously we'll put uint because time can never be a negative number. So we'll just put it as uint timestamp. We'll name it timestamp. It's equal to the block dot timestamp. I know this stuff here might be a little bit confusing, which for now, we'll just go with it because it will be very difficult to explain this and it might confuse you. But all these are Solidity code that you can actually use to interact and understand what is moving and the block number of the transaction in the blockchain. So this block, the timestamp, basically just tells us the time that it's interacted and the time that it's finished. All right, and the last thing we'll want to know is the block that is on. So uint, let's call it the block number, and we'll assign it to whatever block dot number it's interacted on. And what we want it to do, what we want this function to return in the end, will be our three things that we want. We want it to return these three values that we set: sender, timestamp, and the block number. So what we have to put here is sender, comma, timestamp, comma, block number. And this is where the important part is. You also have to kind of put the front part of the what you want it to return. So in the top bracket here, next to returns, you want it to return address, uint, and uint. So this basically means that the first interaction can only be an address. It can't be anything else because that's how we set it. So the way coding works is it reads in a top to bottom function. So first take the address, then a uint, and another uint. So it can't be any other function. But if you want to change the order, let's say you want to put timestamp first, right? If you put timestamp first, you have to rearrange this to where this uint is first, then the address, then uint again. And you have to change the values here as well to the same order that's in. All right. I forgot my semicolon again. All right. Once we are done with that, that's basically the contract. Just have to compile it, deploy the contract. And there you go. It will give you the address. This is a random address for now. It doesn't matter. The timestamp that I've interacted with it, and the block number that it's on. You guys can see that it actually changes the timestamp as well, because this timestamp is in seconds. It'll just keep changing every second that I interact with it. Yeah. Oh, 420. That's perfect. Yes, timestamp will always be in seconds. So does anyone have any questions for this part? Or any questions about any of the variables that we've talked about today?
Let's have a quick assessment. Can we, let's say, create a local variable contract? Type in chat. Try not to use Remix. Just type in chat. And see what you remember. You can just use mine, copy and paste if you'd like, if that's easier for you. I'm just using version 8.10 or anything above, but you can use higher versions if you want. And what functions do you want to set inside of those local variables? Go ahead and write what functions you want to set. So we've created our contract called local variables. We've opened the contract with that squiggly bracket. Personally, I'm going to create a public unsigned integer called P. I'm going to create a bool public B, and I'm going to create a public address called my address. Then I'm going to create a function called Christian Sensei. I'm going to open and close bracket or parentheses and set it external so it can be called outside the contract. And then I'm going to set my functions for what I want those variables that I set above to be. So I had my uint p. So I'm going to set uint p equal to, let's say, 69,420. Is that a good number for everybody?
I think it's a perfect number.
I set a bool above, so I'm going to create my bool of b and set it equal to whatever I want, true, should we say? Or we'll set it to false so we can change it when we interact with it. And I'm going to set x to equal when we go to change it, maybe what? 5, 4, 3, 2, 1. And I will set b as true.
Actually, I want them to try something, if that's okay.
Sure.
What I want you guys to try doing is adding two things. So one thing that we learned today, which is creating a local variable and writing a string. So what I want you guys to do is try your best. If you guys need help, you guys can always mention me in chat and ask. But I want you guys to write a contract that will give your name, very simple. And until it interacts with the function, it gives your Discord tag at the end as well. So I don't want it to come up as a string with both your Discord name and your Discord tag. I want it to be once the contract or the function is interacted with, then it shows your Discord tag at the end. It's just adding something from the last lesson with something from this lesson, seeing if you guys can see how to merge these two into a contract, into a singular contract. And if it does work for you, well, you'll get your task for the week done.
It's a good assignment.
I won't show the code for that one yet.
A little harder to do it by yourselves, huh? You got to kind of look back at what you've been writing and double check on some things.
All right, if anyone else has any other questions that they want to ask.
Sure,
mean,
Reaper.
yeah.
You can check in our official links to see our first lesson. It's about an hour long, and it just goes through a hello world contract, or how to start off in Solidity, as well as a quick little variables, or a quick little
How do
functions.
you set? If you just want to default string it is zero, it's the same as like, let's say the hello world one. You just have to put it equal to zero. And for Reaper, this is something that we did on the first lesson. So it's just a very simple contract to write hello world, where when you interact with the contract, it would just say hello world. I think the other thing we did for the first lesson was also just talk about the different types of values there are. Structure is very similar to Python, actually. The only difference is the the words that they use to define different variables and everything. Other than that, it's very similar to Python. If you know any background for coding, it should be very straightforward. It's just a change of words. So if you want, I can actually run through this very fast for you. Should take about 5 minutes if you want to stay back. For the rest of you um, who have been through the first lesson and you guys just want to call it a night, because I think most of you are 30-10 for you guys. You guys can feel free to leave or stay and rewatch what it is to do Hello World. But please try to get the task done. Other than that, I will just do a very quick run through for Reaper. All right, so what we did the last lesson. Let's just write a new one. So I'll run through even the first two lines for you. So the first line that we always put in any contract is called the license. So if you interact on a contract without the license, it will flag up anytime you interact with it. So this MIT is a free license that a lot of contracts uses. There's many other ones out there that you can actually find. You just have to search online which other licenses there are if you want to try different ones. But for our class, we're just going to use the standard MIT. Then for the next line, pragma, Solidity. So this just tells the contract that we are writing using Solidity. And what we're going to do is write which version of Solidity we're using. So the different versions of Solidity that are available as of now is from 0.4.0 to the highest one right now is 0.8.13. And the very important thing that you have to put in this line is actually this little, I don't know what it's called, sorry, but it's this little arrow up to indicate that this contract will work for any software facility that is this software and above. Yeah, version above. Then just to write a very simple string to say hello world is just you're writing your contract and you're just going to state the name of your contract. So we're just going to call it hello world, right? You're going to open up a squiggly bracket to edit your contract. You're going to define it as a string because there's going to be words in it. If you define it as uint, you're not going to be able to type any letters or any words in it. You can only type integers. So we're just going to define it as a string. We're going to make it public so that people can see it. And we're going to name our string. So whatever you name it here, it doesn't matter. You can name it hi, you can name it greet, whatever you want. Once you've named what you want it to be, what you're going to do is you're going to write whatever you want it to say. So you can say hi, sorry, I just want to make sure I spelled the name right. Okay, and then at the end of most of your lines, or almost every single of your lines, you always want to end with a semicolon so that the contract knows that that's the end of that it's going to move on to the next thing. And just perfectly, the next thing is it closes the contract for us. So once you're done with that, you can actually compile it and it will run perfectly fine. So if we deploy the function, if we deploy the contract and it greets, just say, hi Reaper. Yep. So that's basically something that we went through in the first lesson. And that's something that you need to use for the assignment that I just gave. Something like this, but you just have to change a few things here and there. Add it with what we learned today. All right, is there anyone with any other questions? If I wanted to add this to a file for projects, yes, okay. So let's say you want to create a new folder, right? So let's say first you have to create a folder. Right, sorry. Make sure that you're not highlighted on anything. You just create a folder. Let's say that this would be Solidity class. I can't spell. I'm really tired. Sorry. And what you want to do is if you want to create, yeah, I'll type out the assignment, Matthew. Once you want to create a file inside this folder, you have to click on the folder where it's highlighted and then click to create a new file. In Remix, you can't really drag and drop, which is really annoying, but this is the only way to like organize your files. So if you like type something out entirely here and you want to move it into that, you actually have to create a new file, name it whatever you want, go back to the other file, copy paste your code, and then it will work. Yeah. Any other questions for be it Remix, be it Solidity, whatever you guys need?
Nice. Kind of a difficult task. So again, if you need any help throughout the week, tag Christian, or you could tag myself if you want. You'd be better luck tagging Christian. You lost me at welcome to our second Solidity class. Hey, you're a funny guy. Nice. So we still have our invite giveaway going. Feel free to invite people to classes. We're giving away some hard wallets, some Ledger Nanos to protect your crypto assets. It's very important. So yeah, we want to give some out. Whoever's got the most invites by April 29th. That is the official date. We will be sending these right to you. We have class tomorrow featuring Jangle Leg Jones called When Moon, a deep dive into some NFT projects. For all of you who were into Moonbirds this past week, I'm happy to see they're doing very well. For all of you those that are using Celsius, I would recommend you look for other options as they have closed off to new users and are going the BlockFi route. If you don't understand what I'm talking about, we're going to have a class on that as well. But I appreciate you all being here. If you have any questions, feel free. I will see you over in the recess thread, which you can find below, I believe. Yes, below us right now. And thanks for coming to class. You guys are all going to receive some XP for being here. I will see you all next time. Great class, Christian. Thanks for sharing.
No, anytime.